Okay, good evening. This is Professor David Okay, my topic for decision will be uh, system of linear equations on the application problems. On the application problems, this will be a topic on consecutive integers. Consecutive integers. So the main topic for tonight will be consecutive integers, that is under system of linear equations. Okay, let's proceed. The last time around, I discussed what we call this distance problems, and that is still under a topic, worded problems under application of linear equations. So we will be solving another topic on the worded problems, still on linear system of linear equations, but the topic should be on consecutive integers. There are problems coming out from the CAT and SAT exam, okay, and the topics are actually regarding consecutive integers. So to prepare for the study of that one, let's proceed with the concept of consecutive integers. Concepts. There are actually concepts on how to attack problems under consecutive integers. Okay, and there are three concepts needed here. Number one, if we are to look for a consecutive integer without specifying whether it is an even consecutive integer or odd consecutive integer, there is a concept on how to follow, and this will be number one. The representation of the consecutive integers will be n plus 1, n plus 2, n plus 3, n plus 4, and so on. So if the variation of the numbering is like this, in general, they are just plain consecutive integers. Okay. Consecutive integers, it is something like 1, 2, 3, 4, right? So we could not say if it is even or odd. They are just plain consecutive integers. Variation number 2. If the value of n is an even number. Even number meaning it is the number is divisible by 2. The value n is divisible by 2. That's why it is termed as even number. If we are referring to n equal to an even number, it was specified in the problem that it was an even consecutive integer. To bring out the numbers under the sequence consecutive even integer, the writings of the variations will be something like this. And the next one will be n plus 2. The next one will be n plus 4. Right? N plus 6. It is even, so the addition here are actually even numbers. This is 2, 4, 6, 8, and so on. That is for consecutive even integers. So if the addition of the variations are plus 2, plus 4, plus 6, and so on, what will come out will be a consecutive even integers. Next one, the third variation. If the value of n is on odd, meaning it's not divisible by 2, right? If you divide it by 2, it's not exact to be a whole number, so it is considered to be an odd number. So if the value of n is an odd number, if we try to bring out the sequence for it to fall under consecutive odd integer, the writings, the representation will be something like this. It's still the same. n plus 2, n plus 4, n plus 6. Actually, they are just the same. But if this is even, what will come out here will be an even consecutive integer. Okay? But if this is odd, okay, what will come out will be a consecutive odd integer. Unlike on the first one, it is just a plain consecutive integer. It doesn't say so if it is odd or even, they are just consecutive. Okay, so the concepts needed in the solution of consecutive integers under algebra, and this is coming out from the SAT and CAT exam, even in the board exams, because there are worded problems under algebra, and one of the problems that might come out will be consecutive integers. So at least we know the concept on how to compute for the variation of the integers. Will it be consecutive? Will it be consecutive even number? Or will it be consecutive odd number? Okay, let's try to bring out an example problem. Okay, I will try to read the problem. Find for consecutive even integers. Okay, the problem is specifying the number that we should look for will be even integers, right? Find for consecutive even integers such that twice the third integer subtracted from 5 times the first equals 18 more than the sum of the second and the fourth integer. This is a verbal problem, this is a worded problem, so if we must have to translate this one into an algebraic equation to show what is being asked. Okay, so actually we need a representation here. Then we need to translate this verbal equivalent in terms of an algebraic equation. Okay? Okay, let's try to bring up the solution. If n is even, and the problem specifies that what is required is even consecutive integer, so we'll go directly to the third concept. No, second concept. Under the second concept, n should be even because the problem is asking for 4 consecutive even numbers. So if we try to represent the numbers, it should be of the variation n plus 2, n plus 4, and n plus 6. So actually we could represent this one as the first one, this one as the second, and this one as the third, and this one as the fourth. So as a representation, it is this. Okay? N will be equal to the first even integer, n plus 2 will be the second, n plus 4 will be the third, and n plus 6 will be the fourth. Okay, we are done with the representation. In the representation, we should be correct because if we made a mistake on the analysis on the representation, okay, when you translate it to an algebraic equation, what will come out will still be wrong. So just be sure that in the representation, it is correct. I think this is correct because the problem specifies that it should be an even integer. So we will use the concept of even integer here. That to represent the numbers, we will be following this one. n plus 2, n plus 4, and n plus 6. Because the problem is asking for 4 numbers. Okay, let's try to translate what they call this representation to form the so-called system of linear equations. That's why the topic for tonight is application of linear equations, but it is related to worded problems before we will be solving a linear equation. Okay, we will translate that worded problems into its equivalent in algebraic equation. Okay, let's try to form the algebraic equation. Translation. According to the worded problems, okay, twice the third subtracted from is okay, this number should be subtracted from, so there should be a number ahead of it, and that from is actually 5 times the first. So meaning to say 5 times the first, okay, we subtract 2 times the third, twice the third, equals, there's an equality sign, okay, equals to 18 more. Okay? But before this 18 more, there is a worded problem. There is sum of second and fourth. Sum of second and fourth is just the second number plus the fourth number. Okay? It says it is 18 more, so this is plus 18. Okay? So we translate this representation into an algebraic equation. Okay? We should be correct, because if it is wrong, our solution will be wrong. Okay, I will repeat it. 5 times the first minus twice the third equal to the sum of the second and the fourth. And this is 18 more. Okay? So if we are correct on this, and we are correct in the representation, substituting it, 5 times the first is actually n, right? N plus 4 is the third. Twice n plus 4 the third. Should be equal to the second. The second is n plus 2. The operation is plus. It's a sum. The fourth is n plus 6. And it is 18 more. So this is plus 18. So after the substitution of the representation, what comes out is a linear equation. Okay? Involving the unknown n equal to. Okay? My representation is just n. You can use x, you can use y. It doesn't matter. Okay, so after the substitution, what comes out is a linear equation. That's why our topic for tonight is system of linear equations, and this is on the application problems, consecutive integers. Right? So if this is correct, solving for n now, we will be using our knowledge of the so-called fundamental operations. Okay, expand, right? Multiply. 5 times n will be n. We use distributive law here. Minus 2n minus 8 equal to. For the right hand side, there's no problem. The addition, the operation on the right hand side are all plus. So actually we could remove the quantity. Right? So n plus n will be 2n. And 2 plus 6 plus 18, that will be 26. For the left hand side, 5n minus 2n will be 3n minus 8 equal to 2n plus 26. According to the rule, put the unknown on the left hand side and all pure constant term to the right. So 3n, we transpose this to the left, this is minus 2n equal to, this is 26. We want to eliminate this one on the left, we transpose it to the right. It will now be plus. 3n minus 2n is n. Am I still on camera? And 26 plus 8 is 34. 3n minus 2n is n. So n is actually 34. The first consecutive even integer. Of course, the next one should be n plus 2. It will be 36. The third one will be n plus 4, that will be 38. And the next one will be n plus 6, that will be 40. If you try to see, the resulting numbers are all even. That's why the problem is asking for 4 consecutive even integers, right? 34 is 7, 36 is 7, 38 is 7, 47. So our concept on how to solve this is correct, right? So the answers will be 34, 36, 38, and 40. Okay, let's try to check the validity of the answer. I will just go back here. We try to substitute values. So 5 times 34, which is 8, minus twice the n plus 4. N plus 4 is 38. Is it equal to? The second is 36. The fourth is 40. And this is 18 more. This is plus 8. 5 times 34 will be 170. This is minus 76. Will it be equal to? The summation of the right hand side is 94. and 170 minus 76 is 94. We'll remove the question mark because 94 is 94, it is true. So our solution is correct. Okay, that's the way how to solve problems involving consecutive integers. So the key to the solution is try to recognize is it even integer or consecutive integer or odd consecutive integer. As soon as you know the variations for it to be even or odd, okay, apply the concept, make a representation, translate, and solve for the unknowns. Okay, good evening from Los Angeles, Professor David J.